Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're going to do probably a pretty long series of videos about building this Elekit TU-8888 push-pull monoblock amplifier. I'm not going to talk about critiquing anything in this series. We're just going to be building it. So let's get busy putting this thing together. Okay, so now we're at the part of installing these polypropylene film capacitors. And we're only going to be using one of these that came in the kit, which is this guy. It's a 474, which is the 0.47 UF cap. We're going to be using Monoblock for C3, C5, and C6, which are all in the signal path. So we're going to be using Monoblock caps for those coupling caps, but C2, we're going to be using this little box cap. And that little guy goes right up here in the front. And there's no orientation on film caps, or at least these little box caps. It's not showing any. And so I know there's the whole outer foil and inner foil and all that, but they don't mention that in the instructions on installing this little guy. So we're just going to put it in. Again, this guy isn't in the signal path. So there it is. Okay, so the next thing they're showing is they want us to install this little transistor right here. And I told y'all before, I'm not much about solid state electronics, but this is mostly in the power supply. If it had like MOSFET followers and stuff between the tube circuits or in the signal path, I probably wouldn't be as interested in this kit, but this is all just power supply smoothing and control. And so, yeah, I think this is all good stuff. So we're going to get a magnifier and read the number off of this to make sure that it is this 80R1K4P7 device. And it is. So we're going to find the spot on the board where this guy goes, which is back here. And we're going to kind of hold it in place and note where the holes are. And it looks like you want to bend it right at where the leads turn from fat to thin. Just like that. And then this guy is going to sit down on the board like this, nice and flush. And then they're saying before you solder it, to get one of these coarse screws and screw it to the board. So that's what we're going to do. We're going to put our screw in there, get our Phillips head screwdriver, and screw this guy in place. And there's no thermal pad, and it's not talking about, doing any kind of thermal paste or anything. You just want to make sure it's flush with the board. I'll kind of hold it up to a light and just make sure that it is. And then we're going to come over here. And again, there's a little step. And it's mounted just like that. Get our tip clean. Wet the tip. And again, these are fairly close together. So just make sure that you don't accidentally bridge these connectors. And it looks nice like that. Anyway, got that soldered. Next is telling us that it wants to install all the tube sockets. And so we're going to do that. So we're going to find that bag and get that open. And this bag's going to have all four of the tube sockets and the little RCA input jack. So I really like these tube sockets for a PC board, that they've got these braces that hold the tube socket secure to the board, and it spaces them up a little bit so that there's some air circulation underneath the tube socket so it doesn't overheat the circuit board. So, key here is, no pun intended, align the key. And you can see the key slot in the socket. You want to make sure that it lines like that. So let me kind of futz around and get all of these guys installed. And the same thing here, you can kind of see on this socket that there's a gap between those two pins, and then there's a gap between those two pins. It's going to take a little bit of wiggling around to get all these pins, because you can see there's a bunch of them that all have to line at the same time. So let me get those guys installed and I'll show you what that looks like. So here's the two 8-pin output tube sockets, and you want to make sure that these are pushed in all the way so that those pins underneath are flush with the board. Because if you don't get these pushed in all the way, and you'll feel them kind of snap into place, you won't be able to put the top plate on the amplifier when you're finished. And the pins should be sticking through like that quite a bit. Okay, and then what I did on these input tubes is I seated them in all the way, and then I came in and holding the socket flush with the board, or as far up as it'd go, I came in with the tip of my little nippers and pushed over like that pin, that pin, that pin, and the same thing on this one, to make sure that they're flush up against the board when I go to solder them. And so let's solder these guys all in place. And again, this is not a place to skimp on solder. And you can see I'm flooding in a bunch. And this isn't something you can really overheat either, so it's okay to leave the iron on there an extra second or two and make sure that you got, I'm going to kind of dance around here. Because these are going to get some abuse when you're pulling the tubes in and out of the socket. And I'll go over that more later, but I will say these tube sockets do have really tight pinholes, and I actually broke a nice tube pulling it out after I'd put it in. And so I would recommend, if you do have some either dead or really cheap 9-pin tubes that you don't really have any value, before you take a $100 super nice new old stock tube, that you put another tube in and out of the socket 2 or 3 times to kind of stretch the sockets just a little bit so that the tubes are a little easier to pull in and out. Because the first time you put a tube in the socket, it's really tight, and you could possibly end up damaging a really nice new old stock tube if that's what you're planning on using. And the other thing, there's some support, but there's not a ton of support. Like, one of the standoffs sits right here, and then the next one's way over here in the middle of this tube socket, and they have the tube sockets for the output tubes well supported, but these just, they can bend around a little bit. So when you're first kind of stretching the tube socket to make sure that the tubes can come in and out fairly easily, I would put the board like up on a table like this to push the tube in and work it out while you can hold the board, so you're not flexing the board. Because see, when you're holding it like that, it's pretty solid. But I'm telling you, when it's in the amp and you're pushing on it, it's going to be like bending this board around, and it's not going to hurt anything, but it's not great. And they're really tight, these pinholes. And if you've got a tube that you don't care a lot about, it's probably a good thing to kind of use it to break in these tube sockets. And the same on these output tubes. They're really tight tube sockets, which, I mean, is a good thing. You don't want them in there all loose flopping around, but just be warned, they're really tight. So let's solder these output tube sockets to get them finalized. And if you've been watching this whole series, you'll remember that we didn't install that super high precision next to the input tube because I wanted to wait until I had the tube sockets installed to do it, to keep it protected. And there's one. And I would do these 3 outboard ones first to kind of stabilize the position of the tube socket, and then do the 8 in the center. Feels good to be soldering in the tube sockets. And I believe from reading the literature, they are using AC to heat the output tube heaters, which are less sensitive to hum. And then they're using DC heaters for the input tubes. And that's one disadvantage to a PC board tube amp, is that the heaters are, you can see these 2 big fat traces, they're part of the circuit board, and you can't twist those wires like you can on a point-to-point wired system. And so if you're powering the heaters on like sensitive input tubes, you probably do need to be using DC heaters for those to not have hum. Looks like these 2 big fat traces come up here and then run around the back over to here, and then they come around and come up to this front tube. So anyway, there are our tube sockets all installed, and we can check those off of our list. So we've done this guy, and we've done that, and we've done that, and we did C2 up here. Okay, time to turn the page, see what they want us to do next. Okay, here's another thing I disagree with, is putting this little tactile switch in right now. It's something, because they've got it going right here in the front, and it's going to be sticking up real high. That's something I feel like that could get damaged working with the board and attaching things. We're going to put that in as one of our last things. I do want to go ahead and install R2, which is this little resistor here in the front, and it's that special guy that I showed you earlier. And it's this little strange looking resistor. I've actually never used one of these style before, but this is part of the special kit that Victor Kung supplies with his build, and you're going to need to bend the leads up a little bit to get it to fit into the holes. So we're going to kind of replicate what those little blue capacitors had on the other side of the board and do that kind of a thing. And then again, it's not orientation specific because it's just a resistor, but I'm going to put it in just like that, and you can see now it's protected by the tube socket. And then if you're a completionist, you can go back and mark that off of our list, just so you can double check that. But anyway, next we want to install this big power supply FET, and the part number on it should be a K31N60W. So we're going to look here, K31N60W. And this one you don't bend the leads over, but we're definitely going to use this little thermal pad, and it installs on a giant heatsink that is going to keep that thing cool, because it is the main pathway of the power supply. And I believe this design is using this FET as the ripple filter. Now you'll see there's a couple of pins here that goes down into the circuit board, and we're going to be soldering onto those. And then you need to make sure that you put the device into the right hole on this heatsink. So come over here, and you can see that the heatsink is going to sit like this with the pins down. And so it's going to be on that position right there. So we need to get one of our 3mm screws, and they want you to use one of these longer screws, and you can hold it up to the instructions to make sure that you're getting the right screw. And so it goes through there. Make sure the thermal pad doesn't have any dirt or anything on it that would keep it from being flush. So the first thing you want to do is make sure that it's square to the heatsink, right? And that the thermal pad is underneath the device, and it says just snug it down at this point. And then you want to install this whole assembly until it slips in. And the fat part of these leads are going to go through the board, so make sure it's fully seated like that, where the heatsink is completely up against it. And then you want to hold this down when you're soldering this, and I would start with the heatsink. And like I said, you want to make sure that you get the heatsink pin and the board hot, then hold it down like this, and then let it off. And then you know the heatsink is flush up against the board. And we're going to do the same thing on this side. Going to make sure that the pin and the board gets heated. Hold it down, and then let it up. And then we know the heatsink's nice and flush. Then we're going to come in and solder these 3 pins. Try to not get them any hotter than you have to get the solder on there. Again, this is something you want to leave a pretty good little amount of solder on, because there's going to be a lot of electrical energy going through this device. And if this joint failed, obviously the amplifier would quit working. Just like that. Like I've said, leave a nice little amount of solder. Don't try to flush cut these. And then I'm going to put this on the edge of the table so I can really push down on this screw to make sure I don't strip the head out when I'm tightening that up. You want this pretty tight. Obviously you don't want to be stupid and crush this thing, but that's what it looks like when it's installed. And pay attention to this bevel. You do not want to install this thing upside down. The bevel faces up like that. Mark this off. And the next thing is to install all these capacitors. And you can see that there's a whole bunch of different ratings, and some of them look very similar. So don't get these confused. I believe that there's 2 in particular that are the exact same size, but they're very different in value or similar in size. So don't get them confused. So we've got these that are 35 volt 220 UF that are going to be used for the DC heaters, I'm assuming, since they're so low voltage. And you've got two of these, and then we've got a couple of 500 volt 47 UF. Actually, there's only one of those. And then you can see there's a 200 volt 100 UF. I mean, they're a little different size, but they're pretty similar. So don't get those mixed up. And then we've got another 200 volt 100 UF. And obviously, if you get these mixed up, they will explode if you put one of these 200 volt ones in the 500 volt slot. So let's go over where these go. The 47 UF 500 volt is C13. It goes right there. Now, pay attention to this. The long lead is the positive. So put it in the positive hole, put the cap in, and then you can see that little half moon shaped thing down there on the bottom that says negative. That aligns with the stripe on the cap. Just triple check those as you're installing them. Because if you put one of these in backwards, the best case is it pops a fuse. The worst case is it blows the capacitor up, makes a huge mess. And nobody wants that. So the next two we're going to put in are these 35 volt 220 UF guys. And these are C21 and C22, which are back here in the back. Same thing, take the long lead, put it in the positive hole, put it in, and then the negative stripe's going to align with that white half circle or quarter circle. Same thing with this one, positive, negative, bend the leads over on the back side, and there are those two guys. And you can see the negative mark there too. This is probably one of the things that would be easy to get mixed up and would be a total disaster. And so there is a 100 UF 200 volt, and that guy goes over here, C18 and C19, and then again 200 volt 100 UF. That one goes in this C19 right there. So I'm going to go ahead and solder in this little batch, and then when I'm done, I'll show you a little trick that I do when I'm soldering in these types of capacitors, because you really want these guys as flush as you can get them to the top of the board. And so I snip the leads off like this, and then I come back and I grab the board like this, and I push up on the corner of the cap next to this pin and melt the solder and push up, and do the same thing on this other corner and push up. And sometimes, like that one moved a little bit, and so did that one. And then when you're done, they don't move like this. They don't wiggle at all, because they've got a little rubber cushion underneath them, and it compresses that little rubber cushion against the board a little bit. And so that's just a little trick I do when I'm installing these types of caps. And if you look at them and they don't look like they're sitting flush, you can always come back and there we go, that one moved a little more. It's not going to hurt to do that a couple of times, just to make sure you get them nice and flush. And then when you're all done, you can look at them and you can tell they're sitting. The tops are flat and they're flush up against the board. So let me solder the rest of these caps in, and we'll come in and populate the other filtering caps. Well, I hope you're enjoying this build series. If you are, please subscribe to the channel. Please like the video. I got this kit from Victor Kung at VK Music up in Canada. I'll put the link below. And as always, DIY audio is fun. So until the next video, have a nice day.